I'm going to talk about antiderivatives. The same way that we can calculate the derivative of many functions, we can also calculate something called the antiderivative of many functions. In a sense, the antiderivative is a lot like the opposite of the derivative function. There's even new notation when someone wants to calculate the antiderivative of a function. Let me introduce that notation right now. If we wanted to calculate the antiderivative of the cosine of x, we would write this. Now, actually, this means we want to calculate the antiderivative of the cosine of x with respect to the variable x. That's what that dx means. Okay? Now, in order to answer that question, what is the antiderivative of the cosine of x with respect to dx? We need to play the following game. Suppose I asked you to solve this puzzle. The derivative with respect to x of some mystery function, I'll put a blank, is equal to the cosine. All right? Think about that for a minute. Can you think of a function whose derivative with respect to x is equal to the cosine of x? All right? Hopefully you saw that the sine function fits the bill, the sine of x. All right? So because of that, one antiderivative of the cosine is the sine function. Okay? I'm also going to have to put a plus c, and I'll explain why in a minute I have that. All right? That's called the constant of integration. That doesn't mean anything to you right now, but I just wanted to tell you what it was called. Now, let's do another example. Let's calculate the antiderivative of x itself with respect to x. So I'll put that dx. All right? Now, again, to answer the question, what is the antiderivative of x, we have to answer the following. The derivative of some mystery function is equal to x. Can you think of a function that has a derivative with respect to x that's equal to x? Think about that for a minute. You may want to pause the video. Okay, you may have, by trial and error, discovered that 1/2 times x squared fits the bill. For that reason, we would say that the antiderivative of x with respect to x is equal to 1/2 x squared. And I'm going to add that mysterious c, that what I call the constant of integration. Okay? Now, for right now, just keep adding the c's, and shortly I'll explain why we have to add that. But first, I want you to do two examples. All right? So make sure you understand what I just said. Make sure you understand the game that you have to play, the question you have to ask in order to calculate the antiderivative of a function. Okay? And now let's go ahead and try two more examples. So what is the antiderivative of the number 4 with respect to x? Also, what is the antiderivative of the sine of x with respect to dx? So pause the video and think about what you might guess those are. Okay? All right, so I'll go ahead and answer these myself now. So to find the antiderivative of the number 4 with respect to x, the game we have to play, the question we have to ask, is the derivative of what function is equal to 4. For the second example, the game we have to play is ask ourselves the derivative of what function is equal to the sine of x. And for both of these, the derivative with respect to the variable x. So for the number 4, I hope you saw that 4x fits the bill. Okay, so the answer is 4x, and then again we have to add that c. All right, and then for the second one, now cosine isn't going to work because cosine is going to have the wrong sign, isn't it? But maybe you were able to discover that negative cosine, minus cosine, fits the bill. So the answer to that one is minus the cosine of x plus c. All right. So to summarize what we've got so far, we've learned about a new procedure called calculating the antiderivative of a function, and apparently what it returns is a new function that's called the antiderivative of some function. The way that we calculate the antiderivative is by asking ourselves the derivative of what unknown function is equal to that function that we're starting with. Okay? And then lastly, we learned about this symbol that represents antiderivatives that looks like a fancy stretched letter S. Okay. All right. So the last thing we need to talk about in this video is why this mysterious, all these C's. Why do all our answers have to have C's? Okay. Now, the reason is because a function can have an infinite number of antiderivatives. All right? An example hopefully will make that clear. So we all agree that the derivative of 4x is 4. Would you also agree that the derivative of 4x plus 2 is equal to 4? Ah, see the problem? Would you also agree that the derivative of 4x minus 1,000 is equal to 4? Okay, so we can keep adding or subtracting constants all day, and we could actually make a list. We could actually find an infinite number of functions, couldn't we? And all of them would have a derivative of 4. We would also notice that all of those functions differ only by the addition or subtraction of a constant. All right, they all have a 4x plus or minus something. So it's for that reason that we put this plus c, what we call the constant of integration, okay, in order to represent all those possible solutions. Okay?